Supplying assets to the Compound Protocol. Quick Start Guide. The Compound Protocol is a series of interest rate markets running on the Ethereum blockchain. When users and applications supply an asset to the Compound Protocol, they begin earning a variable interest rate instantly. Interest accrues every Ethereum block, currently tilde 13 seconds, and users can withdraw their principal plus interest anytime. Under the hood, users are contributing their assets to a large pool of liquidity, a market that is available for other users to borrow, and they share in the interest that borrowers pay back to the pool. When users supply assets, they receive C tokens from Compound in exchange. C tokens are ERC20 tokens that can be redeemed for their underlying assets at any time. As interest accrues to the assets supplied, C tokens are redeemable at an exchange rate relative to the underlying asset that constantly increases over time, based on the rate of interest earned by the underlying asset. Non-technical users can interact with the Compound Protocol using an interface like Argent, Coinbase Wallet, or app.compound.finance. Developers can create their own applications that interact with Compound smart contracts. In this guide, we're going to walk through supplying assets via Web3.js JSON RPC and via proxy smart contracts that live on the blockchain. These are two methods in which developers can write software to utilize the Compound Protocol. There are examples in JavaScript and also Solidity. Table of contents for this guide. Compound markets. Connecting to the Ethereum network. Supplying on a local host network. Supplying on a public network. How to supply ETH to the protocol via Web3.js. How to supply a supported ERC20 token to the protocol via Solidity. If you are new to Ethereum, we suggest that you start by setting up your development environment for Ethereum. All of the code referenced in this guide can be found in this GitHub repository. Quick Start. Start supplying assets to the Compound Protocol. To copy the repository to your computer, run this on the command line after you've installed Git. Git clone Git at github.com compound developers /compound supply examples.git. Compound markets. The Compound Protocol enables developers to build innovative products on DeFi. So far, we've seen crypto wallets equipped with savings APRs, a no-loss lottery system, an interest-earning system for donation income, and more. The smart contracts that power the protocol are deployed to the Ethereum blockchain. This means that at the time of this guide's writing, the only types of assets that Compound can support are Ether and ERC20 tokens. The currently supported assets are listed here. Compound.finance. Based on the different implementation of Ether, ETH, and ERC20 tokens, we have to utilize two similar processes. The ETH supply method. The ERC20 token supply method. Like mentioned earlier, when someone supplies an asset to the protocol, they are given C tokens. In exchange, the method for getting CETH is different from the method for getting CDAY, CUNY, or any other C token for an ERC20 asset. We'll run through code examples and explanations for the two different asset supply methods. When supplying Ether to the Compound Protocol, an application can send ETH directly to the payable .mint function in the C-Ether contract. Following that mint, C-Ether is minted for the wallet or contract that invoked the mint function. Remember that if you are calling this function from another smart contract, that contract needs a payable function in order to receive ETH when you redeem the C tokens later. The operation is slightly different for CERC20 tokens. In order to mint CERC20 tokens, the invoking wallet or contract needs to first call the .approve function on the underlying tokens contract. All ERC20 token contracts have an approve function. The approval needs to indicate that the core corresponding C token contract is permitted to take, up to the specified amount, from the sender address. Subsequently, when the mint function is invoked, the C token contract retrieves the indicated amount of underlying tokens from the sender address, based on the prior approved call. Example code for each method, JS and Solidity, is available, open source, in the GitHub repository linked above. Connecting to the Ethereum network. You will need to use the contract address for the particular network that you're developing on. Start by identifying the contract address for each network in the docs. In this guide, we'll create a fork of mainnet, which will run on our local host. Copy the mainnet addresses. If you want to use a public test net, like Ropson, Goerli, Kavan, or Rinkeby, make an Infura account at infura.io to get your API key. If you are using your own localhost testnet, or the production mainnet, we will also use Infura. If you are not hosting your own Ethereum node to access the blockchain, make an Infura account before continuing. For more on connecting to a public Ethereum network, see the instructions in. Not setting up your development environment for Ethereum. Supplying to the Compound protocol on a localhost network. To run an Ethereum local testnet on your machine, we will fork the main network, aka Homestead or Mainnet. This means that you can interact with the production smart contracts in a test environment. No real ETH will be used and no modifications to the production blockchain will occur. If you haven't already, install Node.js. Click here to install the LTS of Node.js and NPM. Let's install all of the dependencies required by the project. cd compound supply example / npm install. npm install gnpx. Hash or for Yarn fans. Hash yarn install. Hash yarn add global npx. This will install all of the dependencies listed in the package.json file, as well as a CLI tool called npx. Run this command in a second command line window before you start running the code referenced later in this guide. The command spins up a test Ethereum blockchain on your local host. It also seeds your local host account with ERC20 tokens referenced at the top of the script file. Be sure to add your Infura project ID and Ethereum mnemonic as environment variables beforehand. Hash set environment variables for the script to use. Export mainnet _provider _URL equals mainnet.infura.io Infura project ID here. Export dev _ETH mnemonic equals clutch captain shoe salt awake harvest setup primary inmate ugly among become. .hash runs the hardhat node locally. Hash also seeds your first mnemonic account with test ether and ERC20s. Node /script /run localhost fork.js. The script that we are running uses hardhat to run an Ethereum node locally which has a fork of the history of Ethereum mainnet. We have test ether and test ERC20 tokens that are seeded in the first account of the development mnemonic. Wait for the script logs to appear before continuing. Running a hardhat localhost fork of mainnet at localhost. Impersonating address on localhost. 0x5D3A536E4D6114CC1E35777 BAB948E3643. Impersonating address on localhost. 0x35A18000230275 COC 24873D00FF85 DID550. Impersonating address on localhost. 0x39A39CO21B8 FAC545936693AC917D5E7563. Local test account successfully seeded with DAI. Local test account successfully seeded with UNI. Local test account successfully seeded with USDC. C DAI amount in first localhost account wallet, 100. UNI amount in first localhost account wallet, 10. USDC amount in first localhost account wallet, 100. Ready to test locally. To exit, hold Ctrl+C. To change the types of ERC20 assets provided to the account, uncomment the lines in the amounts object near the top of the run localhost fork.js script. Supplying to Compound on a public network. If you are supplying to the protocol on the mainnet, Ropson, Goerli, Kavan, or Rinkeby, you should have already located and copied the .compound contract address. For that network, see how above. You'll need it for later. You also should have collected some ETH for that network by purchasing /mining main, or a testnet's faucet, all the others. This is not necessary when using a localhost fork. For example, here is Robson's faucet. Faucet.robson.b. You can send yourself one ETH every 24 hours from a single IP address. This is test ETH that is only applicable to the Robson test network. Next, copy and safely store your wallet's private key. Don't do this if you are only testing on your local host. The private key is used to sign transactions that are sent on the Ethereum network. The purpose of this is to certify that the transaction was created and submitted by a unique wallet. If you are using MetaMask for your Ethereum wallet, open the menu, click the three dots on the right, Account Details, Export Private Key, and input your MetaMask password. This will reveal your private key. Keep it safe. Copy this value and save it for later. It is a best practice to store a test key like this as an environment variable on your local machine. When a key is stored as an environment variable, it can be referenced in code files by a variable name, instead of explicitly with a string. This promotes code cleanliness, and reduces the risk of exposing your secret. Again, if you are only testing smart contracts on your local host Hardhat node today, don't get your MetaMask private key. We'll rely on a private key that comes from your environment variable mnemonic. See instructions above. How to supply ETH to Compound via Web3.js. Supplying Ether ETH to the Compound protocol is as easy as calling the mint function in the Compound C Ether smart contract. The mint function transfers ETH to the Compound contract address and mints SETH tokens. The SETH tokens are transferred to the wallet of the supplier. Remember that the amount of ETH that can be exchanged for SETH increases every Ethereum block, which is about every 13 seconds. There is no minimum or maximum amount of time that suppliers need to keep their asset in the protocol. See the varying exchange rate for each C token by clicking on one ad. Compound.finance. For more information on C token concepts, see the C token documentation. In order to call the mint function, you need to first have ETH in your Ethereum wallet. Find your Ethereum wallet's private key. Connect to the network via Infura API key, see above section. Connecting to the Ethereum network. There are several programming languages that have Ethereum Web3 libraries, but the most popular at the time of this guide's writing is JavaScript. We'll be using Node.js JavaScript to call the mint function. The following code snippets are from this Node.js file. In the Supplying Assets Guide GitHub repository, web browser JavaScript is nearly identical to these code examples. Let's import web3.js and initialize the web3 object. It's pointing to our local host's Hardhat node, which has 10,000 test ETH in each of the test wallets. We get the same test wallet addresses every time we run a Hardhat node with a mnemonic environment variable from the connecting to the Ethereum network section. If you are using a public network, Robson, Kavan, etc., make sure your wallet has ETH, and that you have your wallet private key stored as an environment variable. Also, have your Infura API key ready if you are deploying to a public testnet. Replace the HTTP provider URL in the Web3 declaration line with the appropriate networks provider if you are not using the Hardhat test environment. Next, we'll add our wallet's private key as a variable. It's a best practice to access this as an environment variable. If you are writing web browser JavaScript instead of Node.js, you can add the user's private key to the Web3 object by using the Ethereum enable.command. Here is the alternative code snippet. Next, we'll make some variables for the contract address and the contract ABI. The contract addresses are posted on this page. Compound.finance. Remember to use the mainnet address if you are testing with Hardhat locally. The ABI is the same regardless of the Ethereum network that we are using. The next section of code is where the magic happens. The first call in the main function supplies our ETH to the protocol by calling the mint function, which mints SETH. The SETH is transferred to our wallet at address. The three subsequent function calls are not necessary, but they are here for illustration. The first method calls a getter function in the compound contract that shows how much underlying ETH our C token balance entitles us to. The second function shows our wallet's C token balance. The third function gets the current exchange rate of SITH to ETH. ETH. Our code sends 1 ETH to the contract and gives our wallet SITH. The ratio of SITH to ETH should be in the ballpark of 50 to 1. Remember that the exchange rate of underlying to C token not increases over time. Lastly, after the supply operation is complete, we'll redeem our C tokens. This is what a user or application will do when they want to withdraw their crypto asset from the Compound protocol. The first method, redeem, redeems based on the C token amount passed to the function call. The second method, redeem underlying, which is commented out, redeems ETH based on the amount passed to the function call. Finally, we execute the main function and declare an error handler. Here is the command for running the script from the root directory of the project. Node /examples.js/web3js/supplyeth.js. Script example output. How to supply a supported ERC20 token to Compound via Solidity. The following will run through an example of adding an ERC20 token to the Compound protocol using Solidity smart contracts. The full Solidity file can be found in the project GitHub repository. Here. Here's an overview of supplying a token to the Compound protocol with Solidity. Prerequisites. Get some ETH into your own Ethereum wallet by purchasing/mining, or faucets on testnets. This will be used for gas costs. If you're using Hardhat on localhost, you're ready. Get some ERC20 token, in this case DAI. If you are working in the production environment, purchase some DAI for your Ethereum wallet. If you are working with a Hardhat test blockchain locally, your test wallet will receive some DAI when you run the run localhost fork.js script. Get the address of the ERC20 contract. Get the address of the Compound C token contract. C. DAI. On this page. Compound.finance. Order of op. Operations. You. Transfer. DAI from your wallet to your custom contract. This is not done in Solidity, but instead with Web3.j. Web3.js and JSON RPC. You call your custom contracts function for supplying to the Compound protocol. Your custom contracts function calls the approve function from the original ERC20 token contract. This allows an amount of the token to be withdrawn by C token from your custom contracts token balance. Your custom contracts function calls the mint function in the Compound C token contract. Finally, we call your custom contracts function for redeeming to get the ERC20 token back. Let's get started. First, we'll walk through the code in our Solidity file. File. mycontracts.sol. We added contract interfaces. The first is for our ERC20 token contract, and the second is for Compound's corresponding C token contract. We'll be able to call the production versions of the third-party contracts using these definitions. We need to initialize them with the production address of the deployed contracts, which we pass to each of the functions in .mycontract. .mycontract. The first function in my contract allows the caller to supply an ERC20 token to the Compound protocol. We will need to pass the underlying contract address, the C token contract address, and the number of tokens we want to supply. The function first creates references to the production instances of DAI and CDAI contracts using our interface definition. Definitions. Then the function logs the exchange rate and the supply. rate. These calls are not necessary for supplying. They are there for illustration. You can see the amounts and the events output later in JavaScript. Next, our function approves the transfer of ERC20 token from our contract's address to Compound C token contract using the approve method. Finally, our contract calls the C token contract mint function. This supplies some DAI to the protocol and gives our custom contract a balance of CDAI. After we have supplied some DAI, we can redeem it at any time. The following function shows how we can accomplish that in Solidity. The redeem ERC20 tokens function allows the caller to redeem based on the amount of underlying or the amount of C tokens. This is indicated by calling the function with a boolean for redeem type, true for C token, and false for underlying amount. If there is an error with redeeming, the error code is logged using .mylog. Error codes for C token contracts are described in the documentation. Now that we have our code written, let's run it. Compiling. Hardhat has compilation as a simple command in the development environment. The compiler settings are configured in the hardhat.config.js file in the root directory of the project. Run the following command to compile the Solidity smart contracts in the contracts folder. npx hardhat compile. Deploying. Once you have deployed your contract, the script will log the new my contract address. npx hardhat run /script/deploy.js network localhost. Deploying contracts with the account 0SA0DF350D26370965701CBC1C5F30DF76A. Account balance 10 sextillion. My contract address 0x0BB909B7C3817F8FB7188E8FB27630289556E30. Copy this and save it for later. We'll need it to call the smart contract function to supply to compound. Executing. The web3.js code that will invoke our custom smart contract can be found in the example Solidity / folder. Let's run through the web3.js supply ERC20.js script. First, the script makes a web3 object and points it to the blockchain network that we want to use to supply to compound. Next, we make a reference to our Ethereum wallet private key. This should be a wallet that has some ETH for gas and also DAI to supply to compound. Our script's main function first transfers DAI from our wallet to my contract. Next, we make some references to my contract, the DAI contract, and also the Compound CDAI contract. Remember, the C token contract addresses and ABIs can be found here. Compound.finance and my contract's address was logged when we deployed the contract. Finally, we call our main function, which first transfers DAI from our wallet to my contract. Next, we call the supply ERC22 compound function in my contract, which sends 10 DAI to compound in exchange for CDAI. The next two function calls are not necessary for supplying. They illustrate how to get the balance of underlying ERC20 asset in the protocol and the amount of C tokens that my contract now holds. Lastly, we call the redeem ERC20 tokens function in my contract to redeem the CDAI for DAI. The example utilizes the redeem method by passing a C token amount. Under that, there is a redeem underlying amount example, which is commented out. Now we're ready to run. If you are running this on a public network, you'll need to acquire DAI for that network. To execute the script, navigate to the project root directory and run node /example solidity /web3js /supply ERC20.js. If successful, the output of the script will show something like this. Remember that this code will work with any of the ERC20 tokens that Compound supports. You will need to swap in the corresponding ERC20 token contract address and ABI into the JavaScript. Thanks for reading. You are now able to supply assets to the Compound protocol using Solidity or JavaScript. We walked through supplying Ether and also the supported ERC20 token assets. We can also redeem C tokens for those underlying assets later on. There are several code examples available in the Supply Examples GitHub repository. The next key concept of developing a dApp with the Compound protocol is borrowing assets. Be sure to check out the next developer quick start guide, borrowing assets from the Compound protocol. Be sure to subscribe to the Compound newsletter. Feel free to comment on this post or get in touch in the hashtag development room on our very active Discord server.